I've been doing with my other class, and what I'm going to try and do for you guys too is to always record these. That way you can go back and watch a video of the class if you need to go over something again, something like that. As of right now, it will not be recording your questions. So anytime there's a question, you'll hear me answer it, but you won't hear what the question was. So, I mean, that's just kind of how it's going to be unless I get all the kinks worked out in that, and then all you guys are okay with me doing that. So, we'll get there when we get there, but that's the way it's going to be for now. What? Alright. So, let me do this real quick. Trying to figure out if I can turn up my audio a little bit real fast. At least for me to hear. Alright, so yeah, goal is to record classes, so if you missed something or you weren't in, that way you can make up for it. Goal is to get through all of Fasteners hardware and wiring terminations tonight, and then we will move on from there. Did anybody, so I know I need to figure out if the tests can be done at any time or if you have to do them at the class. We have to figure out no. Is that it? Is that the only question I have right now? Just where we're going to take tests before we get started? Alright. So, if everybody can, God dang it. This freaking mic. If everybody can hear me good and everything's good, can, I guess it doesn't matter till I start the PowerPoints anyway, but let me know if the screen that I have up shows up okay while I'm talking. If not, then I will do a screen share of the PowerPoint when we get to the PowerPoints. We're basically just going to flip through the PowerPoints real fast. I looked at them last week. They're okay, but I don't think there's too much I want to go in the PowerPoints in particular, but I want to show them to you just so that it's been done. Other than that, if you got your book, grab your book. If you don't, you're going to want to listen to this later and listen to it so you can highlight stuff. But grab your book, start on Module 1, go to Fasteners and Hardware, and we're going to start on that. So basically all this is just going to be identifying hardware, identifying fasteners, and all that nice neat stuff. And we're going to go through this and see if we can cover everything that that you'll need to know for your quiz. So Module 1, first page, is where we will start. Basically, I'm not going to read this verbatim, obviously, but Section 1 is all the different fasteners that are used. So common fasteners include bolts, pins, screws, retainers. You got to make sure that you select the right fasteners when you're putting stuff together. Threaded fasteners are obviously our most common type. Usually machine bolts, cap screws, nuts, toggle bolts, inserts, flat lock washer, set screws. We want to understand the various types of fasteners so you know what you're looking for when you go to get it. Me personally, I do get irritated, like if people don't know what the hell they want, if they call it something weird. It doesn't happen much anymore, but I've always had guys call some stuff weird things, and you got to try and hunt down whatever that is. You know, thunder nails for hammer set nails and stuff like that for concrete. Sometimes it gets old. But anyway, first thing I want to start with is thread designations. You'll want to note the different thread designations. It's going to be important. Alright, so they've got 3 different thread designations in here. All 3 of them you may want to highlight so that you can remember what they are. Unified National Coarse, which is, I believe, the most common one. Most of your fasteners are going to be coarse, especially 1/4 inch and up when it comes to all thread rod and things like that. So you've got National Coarse, threads used for bolts, screws, nuts, and other general applications. Fasteners with the UNC threads are used for rapid assembly and disassembly of parts where corrosion or slight damage may occur. So national course threads are generally good if you're worried that things are going to get corroded or damaged over time, and you still want to be able to disassemble them, because since the threads are coarser, it's going to be easier to put that stuff together and take it apart rather quickly. I mean, it's just like anything else. If you can if you've got coarser threads, you're not going to be able to fine tune how far that fastener goes as much, but you're going to be able to put it together a lot quicker. So I mean, if you've ever adjusted something, you know, trying to level out an appliance or something, you know, the coarser the thread, the tinier your movements have to be to get it exactly where you want it, but it's easier to get it up and down pretty quick. The next one is Unified National Fine Thread. UNF threads are used for bolt screws and other where a finer thread is required. And then Unified National Extra Fine threads are used for thin-walled tubes, nuts, ferrules, and couplings. So you'll see that a lot, like compression fittings, or I think even flare nuts would probably be extra fine. I'd have to look at one again. But a lot of your compression fittings and things like that are an extra fine thread. My understanding is, and don't quote me on this, but my understanding is basically you can usually get more torque, not torque. How do you put it? You'll get a tighter I'm trying to figure out how to put it. Things will be much tighter if it's a finer thread, actually. You'd think a coarser thread would hold things together better, but the finer thread has more surface area. So if you want to be able to put a lot of torque to something, essentially a finer thread's going to do it. But it's also easier to strip those threads if you go too far. Can't remember where I heard that, but I'm pretty sure that's the way it goes. Don't quote me on it. Anyway, bolt and screw threads are designated by the standard method. The standard designations are nominal size, so your diameter, the number of threads per inch, thread series class, and the thread class. So you got different thread classes. You can read about them there, but generally those are going to be the things you're looking for when you're trying to designate something. If you look at the bottom of page 2, you see those different designations right there. So the technical designation for, you know, that bolt would be 3/4 diameter, 10 threads per inch, unified national course, thread class is 2A, and it's a left-hand thread. No designation if it's a right-hand thread. So if you got a reverse thread, it's going to designate that. If it's a standard right head thread, there will be no designation for the thread. Coarse pitch threads with fewer threads per inch are used in routine applications, offer greater gripping strength when used with larger diameter fasteners. Coarse threads are easier to form and nuts are easier to start. Write down. Fine pitch threads have a higher tensile strength and resist loosening when subjected to shock or vibration. So there you go. It's not, yeah. So coarser threads are going to be better with larger diameter stuff and greater stripping strength, but fine pitch threads are going to have a higher tensile strength. All right, thread fastener grade designations. So I'm not gonna read that verbatim. Basically, just look at your next page. So you have the different grade bolts there on page 3. Your SA grades, you got 0, 3, 5, grade BB, grade BC, grade 7, grade 8, and then ASTM A490. Somewhere in here it told you the 3 most common. I want to say grade 2, grade 5, and grade 8. Yep. So basically, the higher the grade, the stronger that fastener is. So you want to make sure you look for those bolt designations. If you're trying to replace a bolt or something like that, it is actually pretty important that you try and match those designations. Common practice, I don't know how many of you guys put a lot of flanges together and stuff like that, but a common practice is to kind of make your own bolt with all thread. Understand that all thread is not a very high grade steel, okay? We use it for all types of hanging applications and things like that, but it's a relatively I think it would be similar to grade 0 or maybe grade 3. It's just regular carbon steel. So if you need a strong bolt, making your own bolt out of all thread rod, nuts, and washers is not going to be nearly as strong as, say, a grade 8 bolt. So it's just something to keep in mind if you're going to be trying to substitute. Sometimes you can, you need to use a little bit of logic there to determine whether or not that's a good idea. Usually you get away with it. I can't say I've ever gone back to something and say, oh, it fell apart because it wasn't a grade 8 bolt. But know that it's not going to be as strong of a connection. You may not be able to apply as much torque without having issues. Next thing we have over here is on the next page you see a bunch of machine bolts and the different ways we designate those. So you have hex head bolts, hex head cap screws, square head bolts, hex socket head cap screws, continuous all thread double end studs, machine bolts, cap screws. We have flat, oval, pan, round, philoster, truss, hex socket, and torque socket. You got slotted, cross recess type 1, cross recess type 2. So cross recess type 1 would be standard Phillips. I forget what you call cross recess type 2, but there's a name for it. I can't remember the other name for that. Clutch, hex socket, torque socket. So hopefully you guys are familiar with most of those. Everybody knows what a pan head screw is, right? Use that, or use a hex screw for a duct. But all your other ones are right there in case you're trying to figure it out. Alright, nuts. I do want to go over the different types of nuts because you'll need to know which one's which. So nuts used with threaded fasteners have either hexagonal, or square shapes and are used with bolts having the same shaped head. Some special purpose nuts include the following: acorn nuts, castellated or castle slotted nuts. After the nut is tightened, a cotter pin is fitted into one set of slots through a hole in the bolt. So that is a castellated or castle and slotted nut. Self-locking nuts, wing nuts, jam nuts, U-nuts and J-nuts, cage nuts are all your different type of specialty nuts that you may run into. So you want to take notes of those. Next section is thread repair inserts, or helicoils, are a special kind of fastener used to provide high strength and soft metals and plastic. They're used to replace damaged or stripped threads in a tapped hole. Inserts are made in standard sizes and forms, including metric sizes. To insert, which is larger in diameter than the tapped hole, is compressed during installation and allowed to spring back, permanently anchoring the insert into the tapped hole. I can't say I've ever needed a helicoil for what we do, but mechanics use them a lot. So if you ever hear a helicoil and you didn't know what it is, that's what it is. It's basically an insert to repair something that's been tapped, and any of you guys who work on cars have probably heard of it. Got flattened lock washers. So my understanding, this is just an interesting side note, my understanding is that there's only one type of lock washer that works and you never see it. Lock washers are basically a joke. That's what I hear. So I'm not going to attest to that. I can point you to some people that would say so, but my understanding is if you don't have the lock washer, don't cry about it. It doesn't actually do that much to prevent any backing off of a nut or bolt. If you want to make sure that a bolt does not back off, use Loctite. Don't rely on a lock washer. If you really want to make sure it's not going to come off, use a blue or a red Loctite, and that'll make sure that it stays where it's supposed to be. Set screws. Set screws are usually made of heat-treated steel and are used to secure objects or within or against another object. For example, set screws are commonly used to fasten a pulley or gear to the shaft. Set screws are classified by head styles and point styles. All right, so that's how set screws are classified. You'll want to make sure you know how set screws are classified. Set screws are usually headless or blind, meaning the screw is fully threaded yet has no head, and usually it's going to be driven with the fluted hex sockets, slotted or square heads. And then if you look on the next page, you have a diagram of all those nuts we talked about. Excuse me. So if you don't know what any of those nuts look like, you can see what those nuts look like so that you know in case you run across one. All right, screws. Screws are used to fasten materials in a secure manner. Slot types and heads are varied to fit both hand and power drive fasteners. Screw sizes are based on the diameter of the screw and are given in gauge numbers from number 2 to number 24. Screws larger than a 1/4 inch in diameter are sized in fractions of an inch. So anytime you run across a screw that is larger than a 1/4 inch in diameter, those are sized by fractions of an inch. You got lag screws for joining heavy-duty fastening of objects, thread-forming screws. Next page, we got pictures of some cage nuts, helicoils, in case you've never seen a helicoil, and then the different types of washers. And I don't even think any of those lock washers are the one that's supposed to work. I'll have to look that up and show it to you guys one day. But I've seen guys test lock washers. Anyway. Then you go into tap dies and screw extractors. So I imagine most of you guys have seen pipe threaded or whatever. Everybody knows what a tap and die is. Taps are going to make a spot for the screw. Dies are going to generally you're using it to fix threads in the screw or to make your own screw, or you'll use a die to thread pipe. So you have taps and dies. There's different types of taps depending on what kind of threads you're trying to make. Basically, just buy the taps or the dies that are the thread type that you want to put in, and then it'll match that. Fastener extraction. If a bolt is seized in place for a long time, was forced in the bottom of the hole, or becomes jammed in place, it may be hard to get out without it breaking. This can leave it locked in place. In order to remove the fastener, a special tool called a screw extractor is used. Screw extractors are commonly referred to as easy outs. So, where's it? Don't they have a picture of it? Thought they had a picture. Well, yeah, they got a picture of it on the next page. So basically, if you need to extract a screw, your options are you drill a hole in it, put the screw extractor in, pull it out. All right, you reverse the screw extractor and it'll pull it out. Generally, if you're trying to get something that's seized apart, your best option is to heat it up. Heating up the area around it so that it expands will give the screw or bolt a little more room to move. So if you're trying to remove a nut, heat up the nut. If you're trying to remove a bolt inside of a piece of metal, then heat up the piece of metal, and then hopefully as that heats up, you'll have a little bit more clearance there. That works real well. Percussive maintenance works very well. Tapping it. A lot of guys reach for the air curl, the WD-40 or whatever. It helps a little bit, but what helps the most is heating up the area around it, tapping it a little bit to try and get make some clearance in there, basically. Move it up and down a little bit. If it's not locked all the way down and you tap it some, a lot of times that'll loosen it up. And then you can try the lubricants and stuff if that doesn't get you there. But if you break off the head, you'll need a screw extractor. Interesting section. There's nothing on it on your quiz, I don't think. But a good, interesting section to read is torquing threaded fasteners. So 1.3.0, I would read that for your own education for sure. Because there's two types of guy you don't want to be, okay? The guy that just tightens it down as much as he possibly can. And you don't want to be the guy that doesn't tighten it down enough, right? My general philosophy is if you're not sure how tight something's supposed to be, start a little bit loose and you can always work your way up. Like if you're putting together a flare nut or something like that, tighten it down till you think it's pretty snug. If it leaks, you can always tighten it more. If it leaks because you tightened it too much, you're going to have to take it apart and try again. So in general, if you're bolting flanges together, you're bolting something down, if you're able to get back to it later, then you're better off starting with it a little loose and then work your way up. If it's something where you want to make sure it doesn't leak, then find out the torque specs for what you're installing. Find out, if you're doing big flanges or you're doing heads on a compressor or something like that. If you're working on a semi-hermetic, find the torque spec, use a torque wrench, because that's the only way you're going to be sure. All right. So torquing things properly, some of it's feel, some of it is actually the best method is to read the spec and follow the spec. So if you're unsure, see if you there's torque specs for the lugs on a contactor. Okay. There is a specific torque you're supposed to be applying when you tighten down the screw for a contactor to the wire. All right. So in general, anything you want to put together, there's a torque spec for it. If you find the torque spec, then and follow it, odds are you will have no issues. It's very rare that I follow a torque spec and make sure everything's clean and I still have a problem. That's why they sell torque kits for mini splits and stuff now. So because guys have problems making good flare joints, and if once you've used something and tightened something to torque a few times, you get used to it and you can do it by feel. But if you've never felt the correct amount of torque, then sometimes it's really hard to judge it. And in general, the smaller that fastener or the smaller that nut or whatever you're working with, the less torque that's needed. And the best way in my head to think about it is basically if you're working let's just make up numbers. You've got a 1/4 inch nut, right? Say it's got a 1/4 inch surface area. 90 psi on that thing 100 psi on that. To have 100 pounds per square inch of force on that 1/4 inch nut with a 1/4 inch of surface area to the actual thing would be 25 pounds, right? 25 times 4 equals 1 inch. Pounds per square inch would be 100. So for that little 1/4 inch nut, it only takes 25 psi to give you 100 pounds per square inch. Or not 25 psi, 25 pounds of force to give you 100 pounds per square inch. Whereas if you're dealing with a 2-inch nut, okay, with 2 inches of surface area to the mating parts, or however you need to, whatever you actually need that force applied to, that would be to get 100 psi, you would need 200 pounds of force. Does that make sense? It's just a way to think about it in your head. None of that math is right. Okay, but if you're ever looking at it, basically the smaller the diameter or the smaller the fastener you're working with, the less torque it actually takes to reach what you need as far as pressure applied. So same thing if going back to like flare nuts, the little 1/4 inch ones might take 20 foot-pounds, whereas the big ones might be 60 or 70 foot-pounds. It's always like that. So if you're dealing with a smaller fastener, you don't have to tighten it as much as a bigger fastener. All right. So if you look at the next page, it gives you torque in foot-pounds for some typical fasteners. When you're using a torque wrench, if you read the next few pages, it gives you some information on it. So, like I said, I would probably read through that and try and actually understand it. We're not going to go into it in too big a detail because I don't want to spend too much time on it. But in general, when you're torquing something down, if you're trying to follow a torque spec, you need everything to be clean. You need to have a good torque wrench. You don't want to add any leverage to it at all. You want to use just the wrench if at all possible. And you shouldn't lubricate anything. So everything should be clean. You should make sure that the parts go together and come apart very easily, and then you shouldn't add any lubricant. If the parts aren't going together easily, clean it more or get a new bolt, whatever you need. If the threads are a little messed up on one end or the other, that's going to mess up your torque spec. So you may need to make sure everything's smooth, clean, and ready to go. There are situations where people will recommend using a lubricant, if you do use a lubricant, it messes with your spec. It's easier to apply more force. So in general, say your torque spec, and there's none of these that give you a range, but say your torque spec is 48 to 55 foot-pounds of torque. You know what I mean? If it's somebody has recommended a lubricant for whatever reason in that situation, you would start at 48, because it's actually gonna be a little bit more than what you're reading with the torque wrench, because it's moving more smoothly. But in general, the rule is don't apply any lubricants if you're trying to torque something down, because it's not those torque specs aren't made with a lubricant in mind. I don't think there's anything else in there I want to particularly go over. But yeah, knowing proper torques is a good thing to have in the back of your head. Next thing talks about flanges. You can have all different types of flanges, and you want to tighten them in a sequence. So again, if you're working on semi-hermetic compressors or bolting flange pipe together or whatever the case may be, you want to know what pattern you're supposed to tighten those up, just like putting a wheel on a car. Anytime you've got something round, you go across. So 1, 2, 3, 4, 5, 6, 7, 8, however many you got, you go across essentially. If you are unsure, it's usually easy to find something that tells you what the proper tightening sequence of what any given thing is. But we'll just go through this real quick. When tightening bolts on flanges and similar surfaces, the bolts must be tightened to the proper torque and in the proper sequence. Tighten each fastener only a small amount at a time until snug, following the proper tightening sequence for the bolt pattern and the fastener type. After all the fasteners are snug, tighten to the final torque. This prevents warping or damaging the flange or machine part and helps prevent leaks. And it's important to remember, if you tighten one side down a lot and then go to tighten the other side, there's going to be so much on that side that everything's going to be bent. And if it's a metal that will bend, you'll end up bending the metal. If it's not, you'll end up breaking apart. When flanged ends are bolted together, they must be properly aligned. So right there on page 13, after we just talked about under tightening sequences, it says when flange ends are bolted together, they must be properly aligned. That is to reduce stress on the flange faces and on the fasteners as they are being torqued. So make sure you understand that if you're bolting something together, you make sure that it's aligned correctly before you tighten it up. And obviously the general trick you use for that is to put a few of the bolts in, line everything up, and then put the rest of them in. Next thing you got is toggle bolts and anchor bolts. Toggle bolts are pretty good anchors. They tend to work pretty well. Hopefully most of you guys are familiar with the toggle, but if not, you can read about it right there. Anchor bolts. The types of concrete and masonry anchors include the following. 1.4.2. Is everybody following along okay? I know I'm going fast. There's a lot of ground to cover. Obviously pay attention when I'm talking slow if you haven't figured that out. 1.4.2 types of concrete masonry anchors are concrete inserts, non-expanding concrete fasteners, expanding concrete fasteners, adhesive anchors, and Tapcon screws. So I'm kind of picky about concrete fasteners. In general, if you've got a good adhesive anchor, that's nice. So if you're in a spot where you need to make sure it holds pretty good, if you got something like a good Hilti adhesive or something like that, or what's the other company, like Powers or something like that, if you've got a good adhesive to work with, a good adhesive epoxy or something, adhesive anchors work pretty good. I haven't had too many issues with them except in really hollow materials. The expanding concrete fasteners, I kind of like the ones you can bolt down more. Does it go over? Trying to see if it goes over drop-in anchors and stuff. Not a whole lot. The only thing I'll say before we go through all this, just because I don't want to forget, is if you guys have ever installed a drop-in anchor, the ones you put in the concrete that you have to set with a hammer or an attachment on your hammer drill, if that's what you're using, do your best to make sure it's set right. A lot of those things fall out even after a lot many years because they're not set very well. They're not my favorite type of anchor, but they're ubiquitous as hell. Everybody use them. If at all possible, use a setting tool that goes on your hammer drill and do the best you can to make sure those things are set properly. Other than that, in HVAC, we use blues and screws like plastic anchors, toggle bolts here and there. The concrete inserts that you put in, if you're using solid concrete, the ones that as you install it, when you tighten up the nut, it actually makes it expand more, are a lot more reliable. They're also pretty reliable in brick and block depending on the type, so I prefer those over a lot of other types. The only reason epoxy anchors and adhesive anchors aren't used everywhere is because the adhesive is so expensive. And it's just not worth carrying it around and carrying so many tips so that you can continuously use it. But if you're doing production, then they work good. If you need to hang something heavy and you need a really good anchor on it, through bolts it if you can. Through bolt and toggle bolts will always be your best method, or going straight into solid concrete trying to avoid any hollow materials, or go to structural assemblies with beams and beam clamps and strut and things like that. But anchor bolts is something I've gone through a ton, and pick the right anchor bolt for what you're doing. Look through the manufacturer's information on it. They all publish your information. Look at how many pounds it can carry, how well, how to properly install them, so on and so forth, and make sure, because a lot of times you just pick one that works. A lot of guys will just go with 1/4 inch or 3/8 because the rod is strong enough, but the anchor bolts are usually your weakest spot in your chain of supporting something. So when you're talking about heavier equipment and stuff, look at the specifications on the anchors you're attaching things to the structure with, because some of them are not as strong as you'd think. And especially in HVAC, where you can be dealing with some pretty heavy equipment, some pretty heavy duct, you want to make sure you're picking the proper anchors. There's not a lot of information in this book as far as choosing those anchors, but that's something you want to get used to looking at now and then. So Powers Fasteners is a good source of a lot of stuff. I think DeWalt bought them, if I recall. And then Hilti obviously publishes ton of information on anchors. So just keep that in the back of your head all the time. Is this anchor the right anchor, especially if you're dealing with something heavy? And like I said, if in doubt, figure out how to attach it to a steel beam or through bolt it, because you can almost never go wrong with some kind of beam attachment. You can go wrong with drop-in anchors and concrete anchors and stuff like that pretty quickly. It can go bad. It tells you how to install non-expanding concrete anchors. It tells you how to install expanding concrete anchors. You can read that if you want, but my suggestion is read the information on the anchor you bought. It's one of those, it's just like equipment. Follow the manufacturer's instructions. It doesn't matter what this book says. You need to follow the instructions for the anchors that you purchased. However, we will go over installing Tapcon screws real quick. Tapcon screws are driven into masonry or concrete in much the same way wood screws are driven into wood. Using this type of fastener requires that a pilot hole of the correct diameter and depth be drilled into the masonry. So if you're using a Tapcon screw, you need to make sure that you drill a pilot hole into the masonry for that Tapcon screw. You can't just drive it in like it says, like a wood screw. I've actually seen I have actually seen wood screws used as tapscons. It actually doesn't work horribly most of the time when you see it. But tapcon screws, any coarse thread screw, if you drill a pilot hole, will halfway hold in the concrete. But tapcon screws are made to do it. So that's usually your option there. 9 times out of 10, I would prefer an anchor to a tapcon, but tapcons aren't bad. They're not too bad. Then 1.5 on the next page goes into non-threaded fasteners. Non-threaded fasteners like retainer rings, pins, keys, and rivets. So you have retainers and lock rings. Then, those require special pliers most of the time to get off, or some finagling with a screwdriver if you don't have the proper set of pliers. Then you have pin fasteners that you may use, and then you have keys. 1.5.3 talks about keys. Keys are metal parts used to prevent a gear or pulley from rotating on a shaft. Hopefully, if any of you guys have worked on larger motors, you've seen a keyway. You know what a keyway is for, but that's what a keyway does, is it just makes sure that that part, that pulley or whatever it is not going to rotate on that shaft. Just like any other set screw would, but it's a lot more reliable than a set screw. Then you go into rivets, the different types of rivets. Most common one is going to be like a pop rivet. Next one would be a tinner's rivet, for our line of work anyway. But there's plenty of ways to do rivets, but again, in the field usually it's going to be a pop rivet. And then you have your section review. It would probably be good if you answered those questions. That'll help you on your test a little bit. But that is everything on that section on fasteners. Does anybody have any questions on any of that stuff on fasteners? Okie dokie. So the next section in the module is vibration isolation. And I actually thought this would be pretty interesting. And it is. I mean, vibration isolation is a little more complicated than the different types of screws, right? Vibration isolation is especially important in our trade. So it's a good thing to have under your belt, understanding the different types and what we do with it and how to put it together and all that stuff. But for the most part, your vibration isolation isn't something you're going to have to pick yourself or figure out yourself, unless you're really into the design side of things. Usually, even if you need to say selective vibration isolation for a large piece of equipment, you're going to send that information to somebody who sells that vibration isolation, and they'll tell you the best stuff to use. But there are different ways to isolate stuff, so we'll go over a few things in here just to get it out of the way. You got stuff on here on seismic restraint. Obviously not something very important in our area, but it could be important in other areas, so it's good to kind of have it in the back of your head in case you move somewhere where seismic restraint is more important. But otherwise, there's very few times when we have to deal with it around here. So there's different types of vibration isolation. Sometimes you want to reduce vibration from compressors, fans, and blowers. Sometimes you want to reduce vibration transmission between objects. Sometimes you want to reduce vibration transmission through ducts. And sometimes you want to reduce vibration transmission through pipes. And you're going to have different things for those purposes. Compressors, fans, and blowers. Hopefully you guys have seen them before if you've ever worked on any of those things. But you have vibration isolation under compressors. Remember to remove the shipping bracket. Okay, when you get a unit. But You'll have vibration isolation underneath your compressors. You have vibration isolators where your fans mount to your blower wheels. Larger semi-hermetic compressors and even big scrolls are going to have springs instead of rubber. But most of the time you'll deal with smaller equipment will be some kind of rubber vibration isolation. Bigger equipment will be some kind of spring or shock absorber. So yeah, you can read through the compressor, fan, and blower isolators. Skipping over to 2.12, you have vibration isolators that reduce vibration between objects. Equipment vibration is transmitted between the equipment and the object. A common thing to put under there in that situation is, like a neoprene pad. If it's larger, you'll actually need a spring. The next paragraph, when working on vibration isolators, it's essential to ensure the isolator is working within its designated load range. The pad in figure 37, so the pad at the bottom of the page, is rated at 50 pounds per square inch. That means that only 4 square inches of pad of area is needed for a 200-pound unit. If you had a larger unit, you'd need a larger section of pad to handle that pressure. If too much weight is applied, the pad will likely crush too tightly against its cork center and reduce its effectiveness. If underloaded, it will fail to provide good isolation. So the important thing about vibration isolation is you need to load it, right? It needs to be loaded so that it has to do some work, and at the same time you can't overload it. So there's a balance there of do I have enough weight on it that the vibration isolation is going to do its job, but not so much weight that it can't do its job or it fails. It goes down, continuing on to the next paragraph. Residential air handlers installed in attics can be suspended from roof rafters, including multiple threaded rods. Each threaded rod contains its own vibration isolator. So if you're hanging something, you'll usually use a spring isolator on all the pieces of rod. So in figure 35 and 39, note the spring deflection scale. This provides a quick visual means of determining how much the spring is deflected under the load. The next sentence at the bottom of the page, last couple sentences. Loading a spring isolator to somewhere near the mid-range is ideal. For example, if a 50-pound load on each corner of a suspended load is expected, vibration isolators with a maximum loading of roughly 100 pounds would likely be chosen. So if you have a 200-pound unit and you're going to have a 50-pound load on each corner, so the center of gravity is basically the center, so you're going to have 50-pound load at each corner, then you will generally go in between those two and choose a 100-pound capacity isolator. Keep in mind something interesting to note. If you've ever looked at specs on like RTUs and large pieces of equipment, usually the center of gravity is not dead center. And if you look at the specs for that equipment, you can find out the loading for each individual corner. So if you need to know the actual weight at each corner, you can usually look that up for a piece of equipment because it's generally not going to be equal. The compressor is at one side of the unit. The coils are on one side of the unit. It's not going to be equal at all 4 corners. But in general, you're going to pick something in the middle of the 2 ranges so that it won't fail too poorly if most of the load is applied, but at the same time it's not so strong that it's not going to provide any isolation. Okay, next section, 2.1.3. Take note of the first sentence. In metal duct systems, any noise or vibration generated by the equipment can be transmitted throughout the structure. So we may want vibration isolators or flex connectors in ductwork because metal ducts will transmit vibration throughout the structure. In contrast, because the materials used, flexible ducts and ducts made with rigid fiberglass board, do not easily transmit vibrations and therefore do not require vibration isolation. So in metal duct systems, canvas connectors are good because they keep you from transmitting vibration throughout the building. With other ones, the only reason you'd use a canvas connector is really to make it easier to connect for whatever reason. If you're trying to join two sections in the middle and you're not traveling on, starting from A to B. So, yep. If you're putting metal ducts together, it's a good idea to have flex connectors on the connections to the equipment to keep it from transmitting vibration. Then it talks about vibration isolators and pipes. You can see figure 42. That's what a flexible metal vibration isolator looks like. Vibration isolation at compressors is actually a pretty good idea, even though it's not done a whole lot. But especially compressors transmit a lot of vibration to the piping, and that can cause joint failures as well as vibration transmission. I'm actually surprised we don't see it more often than we do, but you'll see large compressors and things like that will have braided connectors made for refrigeration to eliminate vibration throughout the piping system. Then, on the next page, 26, 2.2.0 goes through seismic restraints. In areas with high seismic activity, local codes often require HVAC equipment to be fitted with some form of seismic restraint. Again, it's not something that's required to be known much in your area. I want to gloss over most of it, but keep in mind if you move to an area where it's required, there are things you'll need to know even in residential about seismic restraint. In general here, you'll only see some seismic restraint requirements in large spec jobs. Usually a government or a municipal job or something like that. They may want some seismic restraint in certain situations, but it's pretty rare. So, next section real quick, 2.2.1, seismic restraints for residential equipment. In case you do need to do it, there's several ways to do it. We'll just go through this paragraph real quick. There are several important requirements for equipment installed in a residential environment. For example, residential gas furnaces and water heaters with input ratings less than 100,000 BTUs must use flexible connectors between any rigid gas pipe and the appliance. Furnace and water heaters can be attached to the structure with metal straps bolted to the structure. Furnaces can also be restrained with bumpers. Residential split system outdoor units should be bolted to the concrete pad using a concrete anchor. So if seismic restraints are required and you want to make sure the outdoor unit complies, you would bolt it to a concrete pad using a concrete anchor. Then it goes through seismic restraints for light commercial equipment, hydronic and commercial refrigeration. Then it goes into selecting vibration isolators and materials. And it's like I said, it's a section I would probably recommend you read pretty well. It's not relevant to us most of the time, except for larger rooftops or bigger equipment essentially, but there's some interesting information in there on that stuff. You flip through that. You can go through it gives you the different, I'm trying to find where it was at. There are different, basically in the next section it goes through the different types of housings. So there's like open housings and closed housings, or I even forget what it was called. What were they going over? I don't know. But anyway, there's different types of spring housings and stuff for seismic restraint, so it'll go over that if you read through it. The only thing I want to cover real quick is on the last page though. So if you flip to page 30, it tells you, for example, assume an air handler is mounted on a concrete floor. For simple vibration isolation, open or housed spring devices can be used. If the installation must be resistant to seismic activity, housed spring isolators cannot be used because they can't resist uplift. So that's where I can't find the section where it goes over to housed or not housed. But anyway, there's housed spring isolators and open spring isolators. And a housed spring isolator doesn't resist lifting up. So if you've got an issue where you've got seismic activity, then it's going to come up too much. So it's not going to work. So in general, if open spring devices are used, and the installation must be seismic compliant, snubbers or bumpers must be used. So you wouldn't use a housed one because it can't resist uplift. So you'd use an open one, but if those are used, you have to put snubbers or bumpers on them to restrict back and forth and side to side motion. So I think what they're talking about there, and again, it's not something I can give you too much personal experience on, but essentially it's almost like the isolators you'd see on a large semi-hermetic compressor. It's just an open spring essentially that you put on there to resist vibration. But if you're trying to be seismic compliant, you got to have snubbers or bumpers to restrict it moving too much. Otherwise, it's not going to work well either. So any questions on vibration isolation or any of that stuff? Nope. We good? Okay. All right. Last thing is wiring terminations. Different types of wiring terminations. There's different ways to connect wires. There's plenty of ways to do it. Terminations are often a very nice way to do it. It's pro tip is if you use these terminals, if you haven't done it a lot or whatever. I know when I first started out in the trade, and I know most of you guys are doing commercial and things like that, so it's probably old news, but just in case you don't know, if you're using crimp terminals and things like that, get a good set of crimpers. Okay, don't use your channel locks or your linemans to crimp those wiring terminals on. Buy one of the crimpers, a Klein one, or even the cheaper ones at Home Depot or whatever you can get that have the little round part and then the part that mates with it so that it crimps that terminal on. Even the cheap ones, I don't like those cheap ones that come in those box kits and stuff like that. That you get, at the hardware store, in Harbor Freight or whatever. Those cheap terminal crimpers don't work very well. But I'll tell you what, ever since I first used a real set of crimpers to put on terminals, I've never had an issue, and I'll never do it any other way. So buy a good crimper to crimp on terminals, and you'll want to use them a heck of a lot more than if you don't and you've got those things pulling out all the time. Also, in general, stranded wire works a lot better with them than solid wire, but usually if you got a good set of crimpers, you can even get away with solid wire inside the crimp connectors. Properly made termination should last as long as the insulation on the wire itself. A poorly made termination will always be a source of trouble because it will overheat under load and eventually fail, pull out, or whatever. So you want to make sure you make a good connection. There's a variety Skipping on to the next one, a variety of wiring terminations for stranded wire shown in Figure 50. These connectors are available in various sizes to accommodate from 22 gauge and larger. They can be installed with a manual crimping tool. The range is normally stamped on the tongue of each terminal. Yeah, when you get the terminals, it'll tell you what range of wires you can use. Use the proper terminal for the range that you're working with. If you're using 18 gauge wire, make sure that the range is 16 to 22 or something like that. Crimp type terminations for wires smaller than number 8 gauge are normally made to accept at least 2 wire sizes and are often color coded. For example, one manufacturer color code is red for number 18 and number 20. Blue for number 16 or number 14, and yellow for number 12 or number 10. So, the different colors aren't just there to color code it. If you look at the holes in the crimp connectors, they are different sizes for different size wires so that you get a good crimp on connection. Compression connectors are used for connecting conductors to screw terminals for low and line voltage circuits. Figure 51 shows basic structure of a crimp connector. The crimp bearer receives the wire and is crimped to secure it in place. So if you look at figure 51, where is that? Yeah, so it shows you all the sections of it basically. The V's or dimples inside the barrel improve the wire to terminal conductivity and also increase the tensile strength. And most crimp connectors have nylon or vinyl insulation covering the barrel to reduce the possibility of shorting to adjacent terminals. The insulation is color coded with the connector's wire range to reduce the problem of wire to connector mismatch. An inspection hole is provided at the end of the barrel to allow visual inspection of the wire position. So that is what the inspection hole is there for, is to make sure you have the wire in the correct position. So if you're unsure, look through the inspection hole. For smaller wires sizes, sleeve is crimped over the conductor insulation in the process of crimping the barrel, providing strain relief. Aluminum has certain properties that are different from copper, and special precautions must be taken. Standard copper connectors cannot be safely used on aluminum wire. Aluminum connectors are designed to bite through the aluminum oxide film that coats aluminum conductors as the connector is applied to the conductor. The conductor should also be wire brushed and coated with an oxide inhibiting compound to ensure a reliable joint. So no locks. All right. You want to put a dielectric corrosion inhibitor on aluminum when you use it. We don't do a ton of aluminum around here, but when you run to aluminum, try to make sure it's right, because otherwise the stuff will fall apart if you don't put it together properly. Never use connectors designed strictly for use on copper conductors on aluminum conductors. Connectors listed for use on both metals will be marked ALCU. So if you are putting together connectors on aluminum wire, it will be labeled AL-CU. Installing terminations. You want to make sure that you prepare conductors properly for a termination, okay? So you don't want to I'm guilty of using my dikes to strip wire all the time. Okay, I enjoy it. I'm not too bad at it. If you're not very good at it, don't do it. Okay, you don't want to cut through strands of wire. You really want to use a good set of wire strippers to make sure that you properly strip wire, or be careful not to damage those conductors. And especially if your wire is sized pretty close, you know what I mean? You're using a stranded 12 gauge conductor, and you're going to be putting 20 amps through it. If you've got it right at the edge of what it can handle as far as load, then you want to make sure that all of those strands are in good shape. Okay, so use some common sense. Make sure that you don't damage a wire, especially if it's going to be carrying a high amount of amperage relative to its size. And make sure you don't strip it far, but you strip it far enough to get a good connection. Bad wiring connections can drive you insane. Try not to make them yourself. Fix the ones other guys do. Don't install bad wiring connections. So use good strippers. Keep in mind the integrity of the wire. If it looks like the integrity of the wire has been compromised, then cut it and do it again. If you're having trouble with wires, you're having trouble with control signals or something like that, your best option is to just cut all the terminals and redo them. Okay, so you're having problems at a thermostat, nothing seems to work right, you're not getting any wire, you're not getting good connections, just cut all the wires and redo them, because odds are there's a bad connection there somewhere. It happens a lot. So one of the most important things to keep in mind on the second paragraph under 3.2.1, that last sentence, exposed strands present a safety hazard. So you don't, like, if you're doing 3-phase power, you got a 3-pole contactor with some beefy wires with some multiple strands. You don't want those strands going all over the place. You want all those strands to stay close together and go into the terminal where they're supposed to go. You don't want to cut off strands or mess around. If it doesn't fit in the connector, figure out how to get the right connector in there. But exposed strands are a safety hazard. They're a shorting hazard. They're a headache hazard if you're trying to troubleshoot issues. So make sure you get rid of those exposed strands. Goes through different types of wire strippers after that. And then on the basically the last page of this section, page 34, figure 54 shows the positioning of the wire in the crimp barrel when stripped to the proper length. The conductor insulation must be in the belled mouth of the terminal. So you want the conductor insulation. If you look at that figure on page 34, it shows you if it's stripped too long, it shows you if it's stripped too short, and then it shows a proper stripping. You want the insulation to go in the belled mouth of the terminal so that you have continuous insulation there and you're not going to have any issues. It will also help to give it a little bit more strain relief essentially on that crimp connector. And you'll make sure you don't have any exposed wires one way or the other. So that bottom figure is the proper way to do it, and the conductor insulation should be in the belled mouth of the terminal. And then installing crimp connectors, the next section, 3.2.2. Basically, most crimp connectors are installed with manual tools or plier style crimping tools. I don't know about you guys, but I've never seen another way to install one anyway. So you install crimp connectors with manual crimping tools, and yeah, that's an okay plier they show there, that manual crimping tool. If you're doing a bunch of different sizes a lot, I guess that's nice, but I like the ones that just have the single size. The ones with a single size on it usually work just fine. It's just one single crimp connector, one single spot for the tool there, and that's the best kind. The best kind, you'll see them in Home Depot or the supply house or whatever, the crimping tool that just has one thing for you to put the wire in and crimp it down. Use those. Those work. Everything else, haven't had so much luck with. My experience. And then you've got review questions. So I'm looking through them real quick. You can do those review questions. It wouldn't be a bad idea, but pay attention to the things that I noted in particular and the things we went over, and that should be everything you need to answer all the questions on your quiz concerning this stuff. So with that being said, is there any questions specifically when it comes to wiring terminations? Okay, so everywhere I slowed down and repeated the sentence. So anytime I slowed down, and like I said, I'll put the video up if you want to go and look at it again, but anywhere I slowed down and repeated something is probably an important section. So everything we went over is pretty important, but any place that I slowed down. So going back through it again, if we start on page 1, if you guys want to go with me, I'll kind of give you an idea of where you should highlight. In 1.1.1 thread designations, the different thread designations are important. So you should know Unified National Course. Unified National Course is good for rapid assembly and disassembly of parts where corrosion or slight damage may occur. Unified National Course is an important one to understand. Besides that, you also have the Unified National Fine and the Unified National Extra Fine. Those are your different thread designations that are important. Moving on, nuts are an important thing to remember. Acorn nuts, castellated and slotted nuts, how those work is important, then all your other different kinds as well. But you'll want to know that a castellated nut, you have a cotter pin to fit it in the set of slots through the bolt, and that keeps it from loosening. So castle nuts, and then the rest of the nuts is something you want to pay attention to. Moving on page 5, 1.1.7, set screws, how they are classified is important. In that first paragraph, the last sentence tells you how set screws are classified. You'll want to know how set screws are classified and how to determine which one you're using. The next area we talked about, torque wrenches and stuff, and then we talked about tightening sequences on page 12 and 13. You'll want to know tightening sequences, and you'll want to know that how to properly put them together. And especially on that second paragraph on tightening sequences, you want to make sure that you know they need to be properly aligned. Moving on, you want to know the proper way to install Tapcon screws. And in that first paragraph, basically it goes through it. The second sentence in particular, making sure you know that you have to drill a pilot hole. You can't just drill that in. On keys, we got retainers and lock rings. 1.5.2, we got pins. And then on page 19, we talk about keys. You want to know what keys are for. Key stuff prevent things from rotating on a shaft. So that is important. Then we get into section 2. 2.1.2, vibration isolators that reduce vibration between objects. You'll want to know the last paragraph on that page. You'll want to read through that a couple times and make sure you understand that. When we were talking about loading, you want to know how to load it. So where it talks about loading a spring isolator to somewhere near the mid-range is ideal. That sentence and the next couple sentences on page 23 at the bottom. Basically that paragraph, that last paragraph on page 23 is important to note. The next section, we want to know that metal ducts need vibration isolation. Non-metallic ducts do not. So metal ducts, any noise or vibration generated by the equipment can be transmitted throughout the structure. With other ducts, it is not. And then next one, page 26, you want to pay special attention to 2.2.1 on seismic restraints for residential equipment, and how that on the last sentence it tells you how to seismically restrain an outdoor unit. You want to know how to seismically restrain an outdoor unit with bolts and a concrete pad. Then last thing in that part of the section 2 of the module on page 30, you'll want to read that last paragraph, make sure you understand it. If you don't understand it, read the rest of the section, but you want to make sure you understand that last paragraph on open spring devices. If you're trying to seismically restrain but provide vibration isolation on a air handler or something, you can't use housed spring devices, right? But if you use an open spring device, you have to provide snubbers or bumpers. So understanding that that issue, right? Understanding, you got seismic restraints, you got to deal with that. But at the same time, if you're trying to deal with vibration isolation, how do you handle that? And you want to make sure you're picking the proper type of spring isolator. And when you're doing that, you add anything else you'll need to restrict back and forth and side to side motion. So open spring devices are used to be seismic compliant, but you're going to need snubbers or bumpers. Then on page 31, you want to pay special attention to what the inspection hole for the connectors and terminations are. The inspection hole is provided at the end of the barrel to allow visual inspection of the wire in the terminal. That's what it's there for. You got a little inspection hole inside your crimp connector for a reason. That's what it's there for. You want to make sure, moving on real quick, in the last paragraph in 3.1.0, pick the right connectors for aluminum and copper. If you're using aluminum wire, you have to use connectors that are made to work with aluminum. Any connectors marked AL-CU are good for aluminum. If they are not marked AL-CU, or they say for copper use only, don't put them on the aluminum. Additionally, make sure that you know that you should clean the aluminum wires to get the oxide off of it. Everybody knows, right, that when you're using when you're dealing with aluminum, it keeps from corroding because it forms an oxide layer on the top, and that prevents any further corrosion. But the problem is that oxide layer is also not as conductive as the aluminum inside underneath of it. So when you make the crimp connector, you're going to want to clean off that oxide layer and then put a corrosion inhibiting compound on there to keep a good connection. So it's important to understand how to keep a good connection there on the aluminum, and obviously use no locks or something to prevent that corrosion after the connection's made, and then make sure that the connectors are marked AL-CU for aluminum. You want to understand how to prepare conductors for the terminations, and understand that if you don't prepare them correctly and you have exposed strands present a safety hazard. The last sentence in that second paragraph tells you exposed strands are a safety hazard. Hopefully you understand already exposed wiring strands are a safety hazard. Exposed wiring in general is always a safety hazard. That's why we have all kinds of warnings on doors with electrical in them. But there's no reason to compound that hazard, creating your own hazards by having wires that aren't terminated properly. So, and then on the last page, 34, figure 54 shows the position of wire. The insulation must be in the belled mouth of the terminal. So you want to make sure you know what the proper stripping length is and how to properly put it in the terminal. And that last figure gives you a visual representation of that at the bottom of the page. And then understand how we put crimp connectors together with a manual tool, a plier type crimping tool. They're not electronic, they're not hydraulic, they're just mechanical manual crimping tools. Those are the most important things that we discussed. Does that help more? I won't be this easy all the time. Okay. But generally, here's my style, and I guess I should have explained this better at the start of class. Especially if I'm teaching something where so most of the time I make up my own tests, right? So usually I'll try and make up my own tests on things that I know I covered well. So if I covered something very well, I wanted to make sure that you understood what I covered well. When we're dealing with stuff like this, where it's preset tests are already made up, or if I already made up the test myself before I'm teaching what it's over, then I will generally make sure that I talk at least a little bit slower and try and emphasize what's important. So I'll slow down, kind of try and emphasize what's important, and repeat it to you at least once or twice so that you understand that that's something that's important to remember. We're gonna get into a lot of stuff where I'm not gonna spoon feed these answers to you, because you should read this stuff. You know what I mean? You shouldn't just go through, and when I'm reading through the book, Just listen for me to tell you what's important. Like I said, there's interesting information here. If you look at the torque specs on different fasteners and things like that, it's good information to have in the back of your head. But especially when we get into this stuff later, I'm going to want to cover so many other things that are in here that aren't in here, or expand on so many things. I'm probably not going to be as straightforward on making sure that you guys are prepared for your tests. But I can just about guarantee you that one of my approaches throughout this year is going to be anything that's going to be on your test, I will have said. I will have said it at some point. So, if I've said something, when you're ready to prepare for your test, make sure you go back and listen to everything I said. And if I talked about it, tried to explain it, and if I read out a sentence word for word, then it's probably something you should highlight. I'm not the type, even when I've said, when I do journeyman's preps and stuff like that, I'll say, I'll tell you what to highlight. And even when I say that, I usually don't. I forget to say, hey, you should highlight this. So it's not something that I remember to do necessarily, but I generally do remember to highlight the things that are important for you guys and make sure I've spoken those words. At least once I've spoken those words that you need to know on your tests. So what is after this? I want to double check. So the next class will probably start jumping right into shit. I've been working on all cooling stuff. Control circuit motor troubleshooting. Yeah, it should be okay timing. I'll try because I'm trying to keep the two classes doing the same thing at some point. So right now I'm working on refrigeration circuit troubleshooting stuff. So we'll get into that in Module 3. That'll be at least 2 or 3 classes. These classes are shorter. I kind of got to look at how many classes we have and determine how much time I can spend on each thing. But control circuit troubleshooting cooling and heat pumps kind of goes together. Gas heating, zoning, ductless and variable refrigerant and hydronic are going to be the bulk of what we go over. That's going to be the bulk of our class this year. We'll go through steam, but that's like I told you guys the first class. We'll go through steam, but that'll be mostly reading out of the book. We'll go through oil, but that'll be mostly reading out of the book. We'll go to retail refrigeration, and I'll do the best I can. I have just a little bit of experience in that. And then Module 12, customer relations, will probably be relatively quick, but we'll talk about that a lot. But anyway, that will be the bulk of this year. So I got to figure out how much time we have to spend on those things and not take too much time, but make sure I spend enough time on it. For the ones that I don't know a lot, if you guys know a lot about steam systems or oil systems or something like that, please chime in during class. We can learn stuff together. I try and learn from you guys just like you try and learn from me. So if any of these things you've got information on, butt in and tell us what you know about it. Make sure that I don't forget to say something that everybody should know. But yeah, I wanted to get through Module 1 basically so we could spend more time on other modules. Because most of that stuff, like I said, when it comes to fasteners and stuff, it's important to pay attention to it. It's important to pay attention to crimp terminals. But no matter what the book tells you, the most important information is always the stuff that's going to come straight from the manufacturer. Okay? That's going to be what you want to do. You want to pick things based on code approvals and manufacturer's instructions. You don't want to be like, oh, but the book said Tapcon's good for XYZ or whatever. Okay. How many pounds is it rated for? I don't know. Book didn't tell me, but it's important, right? You don't use a Tapcon to support a 500-pound air handler from the ceiling with duct strap. It might be a bad idea, So yeah, you want to understand fasteners, but the most important things about them are anchors and loading, and then making sure that either you really know what you're doing if you're picking vibration isolation, or you get some technical assistance with choosing your vibration isolation. So yeah, that's how that goes. Any other questions on that stuff? All right. I know it's almost done, but give me like 2 minutes to stretch my legs. 7:24 at like 7:28 to 7:30. We'll flip through the PowerPoints and see if we see anything interesting in there real quick, just so we flip through all the PowerPoints for this, and then we'll basically be done. Read the chapter on your own time, and then we'll figure out when you can take the quiz on that. And next week we'll probably read through the book on the controls troubleshooting first, and then I'll add all my own stuff the next class or something like that. But yeah, give me like 2 minutes. If you guys need 2 minutes, take it now.
No, 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 no.
All right, I'm here. If any of you guys got questions, go for it. I'm not used to. I'm used to standing up for these classes. Sitting down the whole class is still rough. Yep. Mhm. So, you guys are more than welcome to watch the other videos if you want to. I got a little YouTube channel I set up for classes just to make it easy to get to. I will shoot you guys that link through the text. So if you haven't texted me, text me. If you know somebody who hasn't texted me, text me. After this class, I'll set up the group, I'll upload the video, and I'll make sure that there's a playlist that's just the HVAC 3 stuff for you guys, and then all the other stuff is my Fairfax County School stuff. So it's possible on some of these classes I may be like, you should watch the video from the Fairfax County School stuff, because that'll help you out too. But I'm trying to just record them and throw them on a YouTube channel. To be perfectly honest, I'm unsure of any like copyright issues with the PowerPoints and things like that. If anybody brings it up to me, I may cut out the PowerPoints and stuff just to be safe. But I don't think that's something I should get dinged on. But I'll definitely end up deleting them at some point. But because again, this is structured course material. So I'm sure NCCR doesn't want me just giving out the courses for free, essentially. But that's why I'm not reading verbatim out of the book either. Not going to read everything out of the book verbatim because I don't want to do that. But yeah, it's basically just going to be up on a YouTube channel. So you can rewatch the class, do whatever you got to do. Like I said, you're not going to hear your questions because I'm not recording that audio. But you'll hear everything I talked about, and then the PowerPoints will be up at the end or during the class or however we're doing it, and that'll be in there too. So the screen that I'm sharing is the one that's being recorded. So it's not the Zoom. I'm not recording the Zoom meeting. I'm recording through OBS through that screen that I'm sharing. Anything else? So let's just flip through this PowerPoint real quick. So this is the first PowerPoint on the screws and fasteners. So if you're looking at my screen, you should see that. If you guys don't, let me know, and I can try and share it another way. As a matter of fact, you know what? Let me, just to be safe, make sure it's on there and you guys see it good. Let me just share that screen because I think that should make it bigger anyway. So share screen, PowerPoint slideshow. There we go. All right. So fasteners, hardware, wiring, terminations, HVAC level 3. You want to identify the various types of fasteners. You want to be able to identify and explain how to use taps, dies, and screws extractors. And you want to be able to explain how to install and torque fasteners to a specified value. That should be something I'm explaining to you, but I want you to read the book and be able to explain it yourself. All right. But we learned how to identify most of them. We talked about taps and dies and screw extractors a little bit, and we talked about torquing fasteners. There's that diagram on the designating the threads. So again, this is how you'll see threads designated. If you're looking through a catalog or something, it might be listed out like this so that you understand, and you know, that's what each one of those numbers means. So just looking at the model number for a piece of equipment, there's your model number for any particular fastener. All right. The different grades, remember you want to match grades of bolts, and if anything, move up a grade, don't move down grades. You know what I mean? You want to use a strong enough bolt for the application. Grade 5 and grade 8 are kind of some of your most common. They meet ASTM standards. ASTM standards are basically industry standards that make sure that the bolt performs as it's specified. So that's your different grades of bolts, your different types of threaded fasteners. So if you're unsure of any particular type, that's what the different types look like. So if you ever see a bolt, you're like, I don't know what kind of bolt that is, this is a pretty good picture on the different types. All your different nuts and what they look like. Cage nuts. One thing I didn't bring up, but I'll mention real quick, these are cage nuts. I'm unsure. I'm actually unsure if these are similar to spring nuts, but they look a lot like spring nuts. If you ever seen spring nuts that go into Unistrut or something like that, I don't remember reading in the book whether or not these are spring loaded or anything like that, but usually when you see a cage nut like this, it's usually going to be a spring nut, at least in supply houses and stuff that I run in. You see a cage nut, it's usually going to be made for strut. But there's your different ones. There's an interesting thing in the book about jam nuts. If you look at the jam nuts, if you read the section in this book and they talk about jam nuts, I guess the jam nut, and I'm not 100% sure on this, but this is what the book says. So if I understand it properly, you see how that jam nut is right there? The jam nut is supposed to go, I guess, up against the material, and then the standard nut behind it. For some reason, that doesn't make sense in my brain. So maybe that's why they see them wrong all the time. They say you often see jam nuts installed improperly. I would think you would want the standard nut against the material and then the jam nut behind it to lock it, because it's basically just locking that standard nut in place. But they seem to indicate that it's the opposite direction. I can see issues where that may not work very well. Like if you've got a heavy duty nut, I guess you would have to have a heavy duty jam nut. I don't know, man. But that's what they say. So there's your technical piece of information that I can tell you. You will often see opposite in the field. It's not like we use jam nuts for a ton of things in our trade, but they make it sound like you should have the jam nut against the material and not the standard nut against the material, which is counterintuitive as hell to me. I'm not an expert on jam nuts or anything, but that's what they tell me. All right, your lock washers. Your different types of lock washers, including a standard flat washer. Remember, lock washers are not the best way to make sure things don't move. If you really want to make sure it doesn't move, use Loctite. Granted, most of the time, you don't really need a lock washer anyway. But if you really want to make sure that that thing's not going to move because of vibration, use Loctite. Use some kind of thread locker. Do not rely on a lock washer. Anytime you see pumps and stuff like that, if you've taken apart things that vibrate a lot and they're bolted together, the manufacturer a lot of the time puts Loctite on those threads, and they do it for a reason. If there was Loctite on it before, you should probably be putting it back on if you're reassembling it. Just pro tip. Different types of set screws, we talked about those. And then the different ends on set screws. Usually you're going to have that flat end, or usually I see just the normal flat beveled end, but there's your different types of heads and ends on your screws, your set screws. Screw head types, there's your different screw head types. Robertson is your square drive, Phillips, slotted, Star or Torx. The one-way screws are tamper-proof. They don't have a lot of the tamper-proof stuff in here, but there's tamper-proof versions of a lot of these that have like holes in them or something else to make it so that you can't take it apart without a special tool. Your different taps. Taper taps are generally NPT stuff. Pipe taps, taper taps. You have plug taps, bottoming taps, pipe taps. So it's generally going to be either your plug type or your pipe type. But if you got to get down to the very bottom of something with a thread, you got bottoming. And then if you've got a taper that you really need a different type of taper, you got taper taps. Spiral flute screw extractors. There's other designs, but that's the most common one that you see as far as screw extractors. Again, the torque specs. Torque specs on these bolts are interesting. Go through them, understand it. Like I said, you're talking about a 1/4-inch bolt on a grade 8 bolt. It's only 10 foot-pounds, man. It does not take much torque for small fasteners. But you get into these 7/8 ones, I tell you what, you get into 200, 300 foot-pounds of torque, it takes a lot out of you using a torque wrench to get that kind of torque, okay? So understand where your torque generally is, your standard torque values. This is what makes sure that you've got a good connection and it's not going to back off. On small stuff, it's not that much. 3/8 bolt, 25 to 35 or so foot-pounds of torque, not that much. You get into big bolts though, it takes a lot of torque. You need a big torque wrench. Couple different types of torque wrench. Generally you're going to see the click type or the digital. I've never seen anybody use a beam type torque wrench, but they're around if you want them. I don't know where you get them, but they're around. Tightening sequences for bolts. Circular multi-bolt is kind of going to be one of your most common, and then your non-circular multi-bolt for like semi-hermetic compressors and heads and stuff. You'll see the square bolts on some. Like flanged valves and things like that to access check valves or something, but make sure you kind of know what your tightening sequence is supposed to be when you put flanges together. Nothing sucks worse than a leaking flange where you can't get that last leak out of it. There's some trade terms going back for a second. We are probably not going to practice torquing threaded hardware. While you're at work, practice tightening some bolts. If you've never used a torque wrench and you know a mechanic, ask him if you can borrow his torque wrench for a second and play with some settings and see what it sounds like. Or buy a really cheap torque wrench at Harbor Freight and play with it so that you've used a torque wrench before. If you've never used a torque wrench, practice using one, but we probably won't do that. Breakaway torque is the torque required to loosen a fastener, usually lower than the torque to which the fastener has been tightened. Usually, it's easier to back off of the bolt than it is to tighten it, unless it's seized up. Pro note number 2, stainless steel. It's not in HVAC as much, but stainless steel has gotten super common in plumbing. Stainless steel bolts are getting more common. It used to be you never saw stainless stuff. Now you see it everywhere, especially stainless steel threaded pipes and stuff. If any of you guys work a lot in Maryland, for whatever reason, a lot of the supply houses in Maryland have gone to stainless steel instead of the non-lead brass for stuff and things like that. If you're dealing with stainless steel, it seizes up really easy. It galls, okay? So with stainless steel, you want to lubricate it. If you're using two different metals especially, and it's not like a softer metal like brass to the stainless, you'll want to put some kind of, if you're talking about pipe threads or something like that, you'll definitely want some kind of tape along with whatever thread sealant you like to use, but a Teflon tape is good. They make a nickel impregnated Teflon tape specifically for stainless steel. I've never used it. It's not really worth the money if you ask me. Standard Teflon tape is just fine, but you'll want some kind of Teflon tape along with some kind of pipe dope if you're dealing with stainless steel pipes. If you're dealing with stainless steel fasteners, don't over tighten it, okay? Those threads like to stretch and gall, and then you can't get it back apart. If it's hard to assemble, clean it off, lubricate it, whatever you've got to do before you put it together, because a lot of times if you're dealing with stainless to stainless, it's not coming apart real easy. So anything that's corroded can be a pain in the butt, and stainless is always a pain in the butt if you're not careful about resisting galling on those threads. So just keep it in mind. If you got like an imperfection in those threads and it seizes up, it's way harder to get back apart than a normal alloy steel bolt, basically. But usually breakaway torque is less than the torque required for it to be tightened. Nominal size is a means of expressing the size of a bolt or screw by its approximate diameter. A lot of things are nominal size. It's not necessarily the exact size, right? And then rundown resistance is the torque required to overcome the resistance of associated hardware such as lock nuts and lock washers when tightening a fastener. Thread series is the combination of diameter and pitch in threads which are applied to a specific thread diameters to identify the coarseness or fineness of a thread. Remember, you want to know the different ones: UNC, UFC, UNFC, if I remember those right. Anyway, those 3 thread designations. And thread standards are established standards for machining threads, and torque is applying a specific amount of twisting force to a threaded fastener. Set or seizure. In the last stages of rotation and reaching the final torque, a fastener may lock up. This is known as seizing or set. This is usually accompanied by a noticeable popping effect. The tensile strength is the maximum stress a material can endure before being pulled apart, and thread classes are distinguished by 3 designations, which we talked about briefly. You got, and then there's the next section. So, I'm going to stop this one. We'll look at the other one real quick. Or the other 2. There's 2 more we're going to try and go over real fast. That was the first PowerPoint. Next PowerPoint is make sure nope, I closed the wrong one. Give me just a second. Yep, and that's what I was worried about. So let me let me try this first. The heck? Make sure that that's on. Yep, that got on OBS, so cool. Very good. Alright, this next slideshow is... Oh, am I still sharing the screen to you guys? Do you see it? Yeah. Okay, cool. Just making sure. Alright. So the objective and performance tasks for the next section was identifying types of uses and installation methods of fasteners and the various types of vibration isolation. So we talked about that. Selecting the appropriate drill bit to install anchors is important. Although most toggles are virtually the same, there's a variety of head styles that can be found. Head style is usually not the most important thing, but you know, if you need a specific head style for something, you can get that head style on most toggle bolts. You must have a hole large enough to accommodate the toggle, so it's going to be pretty large. So generally you're going to want a washer or something. A fender washer is usually a good choice to cover up the hole you use for a toggle bolt. Concrete inserts, you'll have anchor bolts. You can have non-expanding anchors that use a filler or grout to mount them in place, and they'll usually have some kind of head at the bottom that will basically grip into that grout, and a lot of times it's going to be expanding grout that you use with a non-expanding anchor. And then you have expanding anchors. Expanding anchors are kind of a lot more common for us to use because it takes a lot less work. You got to have a drilled hole large enough for the flat washer to fit, but with minimal clearance. And again, these are for specific types of expanding anchors. Make sure that you look at the instructions for the specific anchor you're using to determine the size of a drill hole. I will probably never look at this table again, and you probably shouldn't either. Make sure you look at the table that comes with the anchor that you are using. Follow the manufacturer's guidance all the time. Different types of locking rings. You see those, we see these in some of our valves and things like that, but it's not super common in the trade, but lock ring pliers are handy if you've got to work with a lot of lock rings. You got different types of pins, cotter pins, clevis pins, and dowel pins are probably the most common ones that you will see. Different types of keyways that prevent stuff from slipping in the shaft. So square keys, Woodruff keys, Pratt & Whitney keys, Gibb head keys. Square keys and Pratt & Whitney are what I see the most. Maybe the other two are pretty common too, but I see the Pratt & Whitney and the regular square keyways the most of the time. Tinner's rivets are pounded to a mushroom at the opposite head to secure a rivet. Blind rivets are installed with a simple tool. Compressor motor vibration isolation. You can see the rubber grommets and the hold down bolts for the compressor vibration isolation. Spring isolators are used on heavier compressors, and there's the different parts of a spring isolator under a compressor. The spring deflection scale indicates how much load is imposed on the isolator. If properly selected, it will not be at either end of a scale. So if there's a scale on the side of it, as it shows it on this picture on the right hand side, you should be kind of in the middle of the scale most of the time. If you're on either end of the deflection of the spring, if it's all the way bottomed out or it's completely loose essentially, then it's not doing anything. And that's why we pick in the mid-range, as we discussed earlier, on a spring. Vibration mounts, some have a spring inside another for additional load capacity. You'll see springs inside of springs. Each individual isolator must be chosen for the weight of the unit at its mounting location. Remember, I was telling you, not every corner of a unit is usually the same weight. It's not, just because it's a 2,000 pound unit doesn't mean every corner is a 500 pounds. It could be 800 pounds here and 300 pounds over there or something like that. So you need to know the corner weights that are provided in the equipment documentation. Flexible connections should be used on metal ductwork. It's not really required on any other type of ductwork. And again, you should practice at work putting together concrete anchors. And that's the end of that slideshow. And we got one more we will go through real quick. That PowerPoint 1. This is going to be on the crimp terminals. Oh no, seismic restraints and maybe crimp terminals? Yeah, seismic restraints and crimp terminals. Start from the beginning. We got OBS, and you guys see the slideshow too, right? Okie dokie. Level 3. After this, you should be able to identify and describe the installation of various types of vibration isolators and the common low and line voltage electrical terminations in hardware. So on seismic restraints, you can restrain a furnace like this. You want flexible connections in the rigid gas lines, and they're showing 2 anchors per angle on each corner of a furnace. So that's one way of providing seismic restraint on a furnace. If you're doing seismic restraints on something that's hanging on like a unit, I don't know if you guys have ever seen it before, but they do. You'll have cables to restrain the unit from swinging. So you'll have your normal supports, a vibration isolator, and then you'll have these cables that are stretched with turnbuckles to the structure to keep that unit from swinging. So you'll see that on large units and large pipes, even in our area. Sometimes they'll require sway bracing. If you ever hear the term sway bracing, it usually ends up looking like this. There's other ways to do it with rods and stuff, but usually it's just basically, some people call it aircraft cable. What's the word I'm looking for? Twisted steel cable. There's another word that I'm trying to think of, but yeah, steel cable. Seismic restraints on pumps. If you got vibration isolation on pumps, you'll need a snubber or something on the side to prevent lateral movement of the pump assembly. Those things can sway an awful lot depending on how those springs are loaded, and especially if you got to deal with seismic restraints, you'll need these snubbers that you see at the bottom to prevent it from moving in either direction, but still let it move up and down with the vibration isolation. vibration isolator selection. There's some 1-inch deflection on different springs. I don't know if this is a standard or not, or if this is from a specific manufacturer, but there's some of your sizes and capacities and the rated deflection of multiple springs. Again, you probably want to consult someone who specializes in spring isolation if you're purchasing some for a particular piece of equipment, or consult the equipment manufacturer on what they recommend. Your crimp-on terminations, you got a lot of crimp-on terminations, the ring tongues, flags, spade terminals, and forks are kind of your most common. The flange forks, you'll see the flange forks or the locking forks on some equipment, but there's all your different types of crimp-on terminations in case you don't know a particular kind. The crimp barrel is the portion where it's crimped to the wire. You got a brazed or butted seam. You have an inspection hole so you can see on the other side. Stud size, conductor range may be stamped on it. The tongue style varies to what we just looked at. And then if it's insulated, you'll have the insulation, and your insulation should go into the funnel, into the belled end, to have continuous insulation. This is a common tool that can cut strip wire and crimp small connectors. Again, this is the kind that I don't like much. I mean, I've never used this particular Greenlee one. Maybe it's nice, but the cheaper ones that look like this are garbage. These are production grade strippers, so if you're doing a lot of stripping, maybe something like that would be nice. I've never actually used one that looked like that. I've never done production stripping. You don't want to strip the wire too short. You don't want to strip it too long. You want to have the proper strip length. It should look something like this. Wire shouldn't extend more than a 32nd of an inch past the end of it. You got your conductor inside. The insulation is in the belled mouth. And then you should practice terminating low voltage wire. ALCU is an abbreviation used for aluminum copper, commonly marked on electrical connectors to indicate that it is suitable with either metal. So AL and CU is what you're looking for generally if you're working with aluminum, because almost everything's good with copper, not everything's good with aluminum. Connectors and lugs. Lugs are used for wire sizes number 8 and larger. You'll have big old lugs, otherwise you're usually using a connector. Seismic activity is movement of the earth, such as during an earthquake. Seismic restraint is a method to prevent or restrict movement during a seismic event. And terminal is a device used for the connecting wire. Termination is a connection of a wire to its destination. And vibration isolator is a device that prevents transmission of vibrations from operating machinery. You are now ready to complete the module exam. And damn, we finished like perfectly at 8 o'clock. So there you go. Any questions? Everybody good? Hopefully it's not just me talking like this super fast in all the classes. But at least we got through this one, and hopefully you guys are good to go. If you got any questions, you can always text me later or something. I will, in the next 20 to 30 minutes, at 8:30 at the latest, I will have shot all you guys a text with the link to where this video should be. If it's not already up by the time I shoot you a text. If you do not see a text from me, please text me as soon as possible. If any of you guys know the guys that did not show up tonight for this meeting, let them know for me to shoot me a text. Hopefully we can hunt down with the last two. I know there's 3 that are missing. One was already said they wouldn't be here. I don't know about the other 2. So I'll figure that out. That's not your all's jobs. But if you happen to know one of them, let them know, forward the information to them, and tell them to text me. But yeah, if you don't see a text from me, then make sure you text me. by tomorrow morning, and I'll make sure you have the information. Other than that, everybody have a good night, and I will see you next Wednesday. All right, all right, later.